All right, so as I said, I want to spend the tutorial talking about a little bit about matrix arithmetic, all right? Which would involve uh, addition, subtraction, multiplication, multi, uh, we wouldn't say inverse, but we wouldn't say division, but we say inverse of a matrix. I would guess by now, you had watched did you all get a chance to watch the videos I sent? Anybody
Yes,
watch it?
sir.
Okay. Yeah. So let's start with some basic addition. All right. Let me start with some addition. So I'll just do one example because it's very simple. Eh? Let's say you're adding what's that? Four. Let's just make a matrix up, 2, 1, 0. Okay, adding that to and you remember that for two matrices to be added, they must be they must be of the same size or order, uh, right? The dimensions must be the same, right? So that's a first condition you must check. The matrices are not the same size, you just can't add them, right? And what do you do to add matrices? You just add corresponding elements. You add this number to this number, you add this number to this number, you add this number to this number, and right, and you go on like that. And your answer should be, let's say 6, 8, 7. Check by yourself. See if they're correct. 5. Hmm? Is that it?
Yes, sir. Yes, sir.
Great. Right. So we got a little bit of addition there, right? Let me leave it there for a moment. So that some of my friends will uh, digest it. Let's go to a little bit of subtraction. All right, let's go to a little bit of subtraction. Okay, let's have another matrix. Let's cook one up. Is it the same one we had before? Subtract. There you go. This one, yeah. This one should be a little more centered. And what do you do now? You subtract corresponding elements, right? You take 1 and you subtract 2. So you should get -1 here. You take 2. Minus 3 should give you 5. And check to see whether all these are not true. Are you checking or are you sleeping?
Yes, sir.
Great. Yeah. Somebody is working with me. I hope the others are checking, right? So let's do okay. We switch over to so we did addition there, we did subtraction. These are the easy stuff, right? These are the very easy stuff. So we're gonna get complicated in just a moment. So let's go to, all right, a little bit of multiplication. We'll start with the very easiest, what we call scalar multiplication, right? Scalar multiplication. Maybe you can take a little example. Maybe you have 4, 5. You know, something like this. And you simply multiply the number in front by everything, right? Inside. And what do you get? Right? Looks correct?
Yes, sir.
Great. Yeah. Somebody's following me. So let's go to matrix multiplication, or where you have two matrices to multiply. It's not a number in front by some matrix, which is so simple, right? Going to a situation where you have some matrix multiplied by another matrix, right? So let's cook up a matrix 4, 5, 7, 2, 1, 0. Let's go with that. And this will be what? A 2 by 3 matrix. I'm going to multiply it by, you don't have to put it up here. You can just put it in matrix, right? So we're going with 2, 3, 8, 9, 1, 1. And this is a 3 by 2, right? So remember, like matrix addition, subtraction, you have to check for a condition. So here you have to check that the number of columns in the first is equal to the number of rows in the second. So yes, you can multiply, right? Yeah, you can multiply. They must be equal. And your answer is going to be a 2 by 2 matrix, right? You're going to get a 2 by 2 matrix in the end. So how do you go about doing that? How do you go about doing it? Well, in matrix multiplication, you multiply rows by columns, right? So you're going to take this row, multiply it by this row. I'm sorry, this column. And you're going to get this first number here, right? There. Then you're going to multiply this row by this column, and you're going to get this number here. Then you're going to multiply this row by this column, and you're going to get this number here. And then this row by this column, you're going to get this number here. And I hope you have your books open, so I'm trying to work it out. You know how to do it, right? Let me just, okay, 4 by 2, all right. Let me just do what? 4 by 2 plus 5 by 8, 5 multiplied by 8 plus 7 multiplied by 1, 7 multiplied by 1, and that's all. That whole sum is going to come here, right? And you should get what? I think you should get 55. Right? Then you do this row by this column to get this number here. Let's do that. Let's do it here. 4 by 3 plus 5 by, what's that, 9? This is a 9, right? 9 plus 7 by 1, right? And 64.
Yes, sir.
Yeah. Then this row by this column, see if you get the numbers 12. And this row by this column, you get 15. That's your answer. Check it out, see if you're getting it.
Yes, sir.
Right. So let's deal with an inverse, right? Let's deal with an inverse. And what's wrong with my copies of both? Let's deal with an inverse. And here's where it's going to really get complicated, right? So let's say we take the matrix, let's call it A equal 2, 1, 1, 1, 2, 1, 1, 1, 0. Right? And you have to find a whole lot of things before you can find the inverse, right? There are lots of methods too out there, right? To find the inverse. But we are going to only use maybe one or so, right? Because remember, this course has a certain amount of time to do. If I were to get into matrix, um, you know, all the fancy ways of finding the determinant and inverse. Matrices, as I said, is a whole branch, right, in mathematics. As a matter of fact, there's a branch called linear algebra, and it's predominantly matrices, right? But we're gonna go with something very simple, right? So let's start. You have to find a number of things. One of the things you first thing you gotta find, and you write it down. You gotta find what we call the determinant, right? Because the determinant tells you whether the matrix has an inverse at all, right? If your determinant is 0, well, there's no inverse. So you don't need to do the other steps. To get a determinant, you have to multiply the determinant, which you call A with a little bar on the side. And you have to multiply that what we call the adjoint. Adjoint of E, right? Or E, adjoint, some books will tell you. For you to get the adjoint, you have to get something called the cofactor matrix in the first place, right? You have to get the cofactor matrix. And then before you get this, you have to get what you call the minor matrix. Minor matrix. Some books say the matrix of minors. Right? So you have all of these things. So let's start with one at a time. Right? Let's start with this one. So how do we find the determinant? And there are more than one ways. If you watch the video, you will see that, okay, the determinant of E, let's write that down, the determinant of E is equals to, if you use this, you can use any rule, but I have a customer that does use it for us, right? You start with that 2, and what you do basically, you cross off the row with the 2 and the column with the 2, and you take this. All right, let me do that. 2 times the determinant of 2, 1, 1, 0, right? And you know we get that. You take this 2, cross off the row, cross off the column with it. And the remaining 4 elements you have there, make it into a matrix, and you're finding the determinant of that. And the sign convention goes from plus, and down here is minus. And then you use the second number, now 1, you put 1 here, times, and again you cross off the row with the 1 and the column with the 1, and you're left with 1, 0, right? 1, 1, 1, 0, right? So you get 1, 1, 1, 0. And then plus again, take this last one here. Cross off the row with the 1 and the column with the 1, and you're left with 1, 2, 1, 1. So you put 1 here. 1, 2, 1, 1, right? And this is going to give you your determinant. So let's see. 2, well, the determinant here is 1. 2 by 0, 0, minus 1 by 1 is minus 1, right? So minus 1. From here, 1 by 0 is 0, minus 1 by 1, which is minus 1, right? So that minus 1 and this minus 1 will come out. All right, let me use minus 1 by, let me do that. Plus 1 by 1 is 1, minus 2 by 1, just right? Is 1 minus 2, which is minus 1. Let's see what we get. You get minus 2 plus 1 minus 1. And you get, let's see. Minus 2, you get?
Yes, sir.
I think in one of the videos, I think so. I can't remember exactly, but there was another method where they take the matrix, right? You take the matrix. 2, 1, 1, 1, 2, 1, 1, 1, 0. And you take these 2 columns here, put them back here. 2, 1, 1, 1, 2, 1. And you take these numbers, multiply them, and add them up, right? So let's go. 2 by 2 is 4. Okay, 4. 1 by 1 is 1 plus 1. 1 by 1, 1, right? And you subtract from that, I think it goes like this. These 3 by these 3 by these 3, right? So what do we get? 1 by 2 by 1 is going to give you 2 dots. 2 by 1 give you another 2 dots. 1 by 1 by, okay, 0. Let's see if we get the same answer, I hope. No, I'm not getting the same answer. Oh, no, watch here. 2 by 2 by 0. I kind of, yeah, this has got to be 0 here. Yeah, made a mistake there, yeah. So you get 2 minus 4, which is minus 2. Right? We made a mistake here. 2 by 2 by now will give you 0. Right? So regardless of which method you use, and in your own sweet time, if you want to experiment, take the second row and do the same thing and see, right? The sign convention for the second row will be minus, plus, minus, and not plus, minus, plus, right? So that's a little tricky. So we have our determinant. It's minus 2. Try 2 methods and get it. So next you have to get our adjoint matrix, but this is not easy. This is not easy. A long process, right? We have a long process to get uh, the adjoint matrix. So what we need to get, first of all, we need to get what we call the cofactor matrix, right? Cofactor. And to get a cofactor, you got to get what you call the minor matrix first, or the matrix of minors, right? So that's a little work all by itself. So let's see if we can get that, right? I'll have to, what can I do? I can, yeah, erase all of it, and yeah, just keep the, yes, I'll erase all of it and keep just the just the determinant, right? Let's do that. So the determinant is -2. Please keep that in mind. So oh god, yeah. So while we erase it. So we found out that the determinant of A equal -2. Save that, right? So we got to get our adjoint of A. So we got to get the cofactor matrix. But before we get it, we have to have what we call the matrix of minors, right? So all of that, a lot of work, right? So how do you actually get that, right? You have to get what you call the minor matrices, right? The minor matrices. And well, how you get that is, this is what you do, right? Basically, you take each element of this matrix. You cross out the row and the column, right? And what you get is you will be left with what you call a minor. So for this two here, if I were to cross out that and that, this is my what you call a minor, right? The minor matrix of this element 2, right? This is like a submatrix that you get, right? And you calculate the minor from it, right? You calculate the minor from it. So you have to actually find the determinant of 2, 1, 1, 0, right? Good. And the sign that will go, usually the sign convention, I'm not going to get into that in the notes I actually, and in the video I actually showed you a very long one. So the sign convention is usually, okay, a minus, plus, and then a minus, and then down here. Sorry, what's happening to me? Starts with a plus. My sleeping. Yeah, starts with a plus, and then a minus, then a plus, then you go with a minus, then you go with a plus, then a minus, then you go with a plus, a minus, and then a plus. This is a sign convention. And here you put the determinant of the minors, right? The determinant of the minors, right? That's what you do here, right? That's what you have to do here, right? Find all the minors, lots of work, right? So first element here, 2, the minor matrix is this. And the minor of itself, which is a single number, is equal to 2 by naught is 0 minus 1 by 1 is -1. So you get -1. So down here, right? So this minus 1, remember there's a plus here. So it all becomes minus 1, right? That's the minus 1 or the plus 1 is a minus 1. I'm just going to do maybe these three, and then you will fill in these, right? So we're going with this element here, 1, right? So you cross out this column, this row, and you're left with 1, 1, 1, 0, right? So you're getting the minus 1, 1, 1, 0, right? We'll have to find it, the determinant of that, which is 1 by 0 minus 1 by 1, which is minus 1, right? So that minus and this minus becomes a positive 1. Right? So if I were to let me at least help you with all the cofactors that you will get. And well, let me say, I'll have to remove, let me remove one. And my computer mouse this morning, so I'm going to drop big matrix here. Let me see. Big. Right? So you start with, as I said, minus, and it will be 2, 1, 1, 0. Okay. Then we're going with what am I saying? Is a plus. Starting a plus. Then you go with a minus here. 1, 1, 1, 0. And then you go with a plus again. 1, 2, 1, 0. Right? From here now you go with a minus. And you get 1, 1, 1, 0. Plus here. 2, 1, 2, 1, 1, 0. And then minus 2, 1, 1, 1. And the last three of them, we go back to plus. Plus 1, 3, 2, 1. Good. Right, so um, I did the first one. Maybe let me show you the last one, how you got on it, right? So how do you get this now? This. I told you this is the sign convention. So you don't have to ask where I got it. This is the sign convention from the formula that I gave you in the lecture, right? Where do I get this? You take this one here and you cross out the row and the column. Huh? Row and the column. So you have 1, 1, 2, 1. Right? So what's that? 1, 1. Did I get that right? 1, 1, 2, 1. I got that. Yes, it's 1, 1, 2, 1. Right? Good. Where do I get this from? Cross off this here, right? The row and the column, and you get 2, 1, 1, 1. See that? So that's what I'm gonna do. And this third one, you cross out where 0 is, you cross out the column, the row, and you get 2, 1, 1, 2. Right? And that's the zero. So you have to find all these little determinants. Find all these little determinants, right? Let me see. Help yourself there. I hope you all are. I hope you all are trying it. So yeah, so you got it there now. So it's equal to one. It's going to equal to one. So if you're getting minus minus one minus one, minus one, minus one, three. Right? So you're getting that. Any of them, well, let's check them at one. Let's take this one. 2 by 0, 0 minus 1 by 1, which is 1. So 0 minus 1 gives you that. Let's check maybe this 3. 2 by 2 is 4 minus 1 by 1 is 1. 4 minus 1, 3. See? The numbers are coming out. You can check every one of them. Guys, I would think by, you remember your CXC stuff, how to find the determinant of these derivatives. Now that you have, or what we call it, cofactor matrix, the adjoint matrix now, adjoint matrix. So A adjoint, E adjoint, right, is going to be the transpose of this, right, which is transposing that one. Take the row and make it into a column. So you get minus 1, 1 minus 1. So I took this row here and make it into the first column. I'm taking the second row, 1 minus 1 minus 1, make it into the second column. And this one here into the last column. Right? So the inverse of E, is equals to the determinant of E, right? Okay, so it's 1 over the determinant of E times the adjoint of E, right? So what are we going to do? We're going to just take, okay, we got the adjoint, we got the determinant, it was what, minus 2, right? So you get 1 over minus 2 times, you say, right? Yes. So your answer is going to be, so A inverse, so it's going to be what? We just multiply this in the back, right? So you get positive a half, negative a half, positive a half, negative a half, positive a half, positive a half, positive a half, positive a half, negative 2. Yeah. I know it's probably, but that's it. Are you checking it? What was the original?
Yes, sir. It's a long process. It's a long process. And therefore, you have to be very careful. You have to know how to find
a lot of things come into play there. You said you have to figure out determinant, determinant, right? Uh, you have to determine the minor or matrix of minors, right? And then you have to get the cofactor matrix, right? You could do these two in one, right? Where you use the convention plus minus plus, minus plus minus plus minus plus, right? You use this, and here you put all the cofactors, right? You can do them in one. Don't do them in pieces. It take more long, right? And then lastly, you have to find the transpose of the cofactor matrix, and that is equal to the adjoint matrix, right? The transpose of the cofactor matrix is the adjoint. And then you take one upon the determinant of, let's say, A times the adjoint of B. When you multiply these two, you get your inverse, right? Inverse, A inverse. Very long process. And as a big help, y'all are smart children. They're infinite, if you know how many, what do you call, matrix calculators online that can help you to check your answer, right? Know the process, because I'm not going to give you something in the test that will you just take some calculator online and punch numbers in, right? It's going to be a little more complicated than that. So make sure you know the process, you understand the process. I also, in the notes as well as in the video, I showed you a number of properties, and so you must know those properties because it can be very tricky. Right? And if you don't understand the properties, and there are exceptions for some of those properties, you know, uh, like when we talk about matrix multiplication, it's generally not commutative, right? We said that. But then you might find that when you multiply a matrix by its inverse, well, whether you put the inverse in front or back, you get the same thing. And that breaks the rule. Right? So those are things you must look out for. Right? There's things you must look out for. Right, so that's a little bit there. Maybe what you want to try one. I want you to try this one. Try this one. I want you to find. Give you one to try for the remaining time. Why are you having me doing all of this? A equal. What do you make of matrix class? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Is the best I can come up with. Find the inverse of it. If it has an inverse in the first place, I don't know. Take a couple of minutes and work on that. Tell me what's going on. Anybody found the determinant?
Yes, sir. It is 0.
Right. Therefore, if the determinant is 0, are you going to waste time finding the inverse?
No, sir.
So it does not have an inverse. Right? Does not have an inverse. So, all right. So that's our tutorial today. Basic the basic operations, you know, to add, subtract, multiply. We went through the whole process of determinants, cofactor, the adjoint, and then calculating the inverse, right? So, yeah, that's it.